Thank you very much for your invitation to this Anticovid Technologies Day. And thank you very much to everybody, especially to SECPHO staff for this opportunity. So in our institution, which is the IMBCNM, is located in the Autonomous University of Barcelona in the campus in Belaterra. Our institute belongs to the Spanish National Research Council. The IMBCNM mission is the research and development of micro and nanotechnologies focused in silicon as the core material. We have five principal research lines dedicated to cover the whole value chain, ranging from materials to systems and from fundamentals to final applications. Well, this is possible because of the combination of being the largest and fully equipped clean room facility in whole Spain. Highly qualified researchers, engineers, and technicians with a very high knowledge and experience in standard CMOS fabrication and in international and multicultural environment. Moreover, the know-how of our staff in CMOS technology is a crucial point in the development of silicon nitride photonic platform for integrated circuits, which is a breakthrough technology in telecommunications and sensing. Well, within the research line devoted to sensors, the chemical transducer group, GTQ, is leading the development in analytical sensors and biosensor systems in the institute. The group is laureate as level A excellence and it's a member of Techno, which is a mark of quality that credits that a group or a center meets the requirements and that guarantee the quality of services, innovation, and together with the use of leading technologies. The engagement of the GTQ with the industry, despite other quality labels, comes from the fact that is one of the few research groups in Spain having the ISO 1901. Well, our group is involved in two COVID-19 detection projects. The first one is COMBAT, and it's an European project led by Professor Laura Lechuga from the ICN2, which fabrication is held by Professor Carlos Dominguez, the leader of the photonic platform within the GTQ, and which objective is for the development of a silicon nitride photonic biosensor. The other project is for the performance of an electrochemical biosensor, and it's led by Professor Cesar Fernandez, who is the GTQ group leader, and it's called POC4COV. So, CONVAC project aims to develop a silicon nitride-based bimodal waveguide photonic biosensor working in the visible range. In this project, our photonic platform develops the transducer, which is CMOS compatible. Also, other partners, such as Aix-Marseille University, is for the development of the bioreceptors, such as the proteins, monoclonal and polyclonal antibodies, this single-strand RNA, etc. So here we can see that the technology used for the bimodal waveguide fabrication is a dedicated device whose technology is based on silicon nitride technology that is mostly used for photonic integrated circuits in order to perform programmable chips, switch matrices for LiDAR application and for quantum computing. since silicon nitride is transparent in the whole range spectrum, including visible, near, and mid-infrared. Well, for the B-model waveguide, the fabrication consists on a 150 to 340 nanometers step of silicon nitride with aims to the generation of the first light mode, having the fundamental mode as input. The generated mode interacts with the biofunctionalized surface, and in presence of the target analyte, the bioreceptor captures the biomarker, and a refraction index change occurs, provoking a shift between the two modes. The shift measurements allow the direct quantification of the analyte. So, in a multiplexed chip, a large quantitative and qualitative screening is performed at once, and the estimated time is to get detailed results is about 20 minutes. Here we can show how the sensor works in an experimental setup. The chip and the microfluidic system might be integrated in a full cartridge for a pick and place inside the device. Well, even though this is still under study. In addition, here we present some analytical results for other previously measured biomarkers showing a high specificity and very low detection limits. Well, now let's talk about the second project we are developing, also for the COVID-19 quick detection. In this case, the POC4COV is a national project with some companies co-founding. Several groups are all from the CCIC Council, which are involved since there are two devices under development. And here, within this presentation, we will talk about the device involving our group, which consists on an electrochemical biosensor based on magnetic nanoparticles for several specific biomarkers detection of the COVID-19. Gold electrodes were fabricated on a chip using CMOS technology, acting as the electrochemical transducers. This is consisting on a reference electrode, as you can see here, and several working electrodes in order to multiplexing the detection points. The support is a kind of paper because of its intrinsic capillarity properties and having some of the reaction molecules immobilized on its surface. The support is placed on the top of the chip, and the electrodes are aligned with the sensing area, as you can see here. Well, gold electrode, here we can see this gold electrode in the final device. From the other side, magnetic nanoparticles are functionalized with the bioreceptors and mixed in a buffer solution. A blood drop of the subject is mixed with the biofunctionalized nanoparticles and drop casted in the sample reservoir. As shown in the scheme, here you can see that the nanoparticles mixed with the blood sample are moved capillarly within the paper until the sensing area. So here, the reaction only takes place when the capture antibody functionalized on the magnetic nanoparticle surface catches the biomarker, since the enzyme is placed in the common region of the detection antibody. The iron oxidation takes place, delivering an electron, as you can see. This travels through the working electrode and the current decreases. And hence, the detection signal that sensitivity quantification. Here we show some preliminary analytical results concerning the detection of COVID-19 cytokines such as the TNF alpha and the IL-8. Well, thank you very much. I hope you enjoyed this small presentation. And please, can I answer your doubts or questions?
Thank you, Jad. We don't have yet any questions, but since we are a deep tech cluster, I think it will be interesting to know how this silicium technology is getting more well known in the community.
Yeah, well, because of several properties, such as, for example, the possibility of the footprint reduction. Here we can talk about circuits of 1 centimeter squares that englobes several components. No, also their properties of the conduction, low losses, large fabrication amount, let's say, in the same time, that reduces the costs very much.
Okay, there's a question from A Húngaro. Says, "Hi, can you please explain better your proof of concept results?" And he says, like, for example, sensitivity, selectivity, time to results, and consistency. Which sample has been used?
Well, this is a very good question, but I don't know if do you refer to the first project, Convat or the POC4COV. But anyway, for the final detection, there are two parallel ways, as I have explained previously, because the project is done with other partners. Here we use for each biomarker a specific bioreceptor, obviously. So, for example, for the proteins, let's say the spike proteins, we use we have antibodies. We have this specific monoclonal antibodies or polyclonal antibodies. We detect sometimes directly, and sometimes we use complementary antibody for the detection. Obviously, here we present some analytical results of other biomarkers. Like here, for example, in this case, the CRP protein, these two hormones, and in for the last project, which is POC4COV, here we present the detection of cytokine. Well, we can say that we are in the step of the TRL7, and we are like in the step of the confirming all the sensitivity, selectivity. Well, the selectivity is already confirmed because we use the specific antibodies and the single-strand RNAs. So there is no normally, when you use such specific bioreceptors, you don't have any problem of interference.